Welcome, everyone. Thank you so much for joining us. My name is Kevin Bolger. I'm with the Tennessee Urban Forestry Council. We'll be moderating the webinar today, and we're really excited to have Sarah Welz with us. Sarah is the Urban Forestry Project Manager with Metro Water Services of the Metropolitan Government of Nashville, Davidson County. She's also a board member of TUFC, and as a Nashville resident, I'm particularly interested in this one. I know we have a lot of Nashville folks, people in other municipalities across Tennessee and then outside of Tennessee as well, who are going to be really interested in this. So before we get started, though, I also want to introduce Katie Donaldson. Katie is the communication specialist with the University of Tennessee and the UT School of Natural Resources. Our co-host and partner for this event series. And Katie's just going to give us a little bit of housekeeping information.
All right. Hello, everyone. So if you are on this Zoom, please make sure, and you're seeking International Society of Arboriculture CEUs, please make sure that you're registered. If you are not a TUFC member, please make sure you have paid the $10 in order to receive those CEUs. And to make it easier for us to verify that you've attended this webinar, please take a moment to change your name to the full name that you registered with. So, and these are the steps to do it. After getting into Zoom, go to the participants icon, rename yourself, and please use the name that you registered with. That just makes it easier for us to verify. Again, the payment does not apply to people who are just attending this with no need for CEUs or TUFC members. And at the end of this presentation, if you have any questions, please enter them in the chat, and we will have a Q&A portion at the end of this webinar. Kevin, I think that's it. Did I leave anything out?
No, thanks, Katie. Yeah, like Katie said, send in those questions on the chat throughout. We'll be keeping an eye on them. Also, we love to know where you're from. We saw when everyone registered, there's people from all over the country, a lot of folks in Tennessee, like we said, but you feel free to give your hometown a shout out into the meeting chat. It's always cool to see where everyone's from. So without further ado, we'll hand this over to Sarah for her presentation on Nashville's Urban Tree Canopy Study.
Awesome. Thank you, Kevin. I appreciate it. Let's get this going. 1 second. This is always the hardest part. All right, let's see. I gotta close this down. Well, I'm really excited that everybody's here. I saw that there were like 45 people already that had been waiting in the chat room. So
yeah, we got folks from Pittsburgh, Memphis, Germantown, Gallatin, Hermitage. Oh, hey, Quebec. We got someone outside of US. Knoxville, Norman, Oklahoma. That's great.
Okay. I think we got it.
Looks
there
good.
We go.
Right. You guys could say?
Yes,
okay.
Ma'am.
Perfect. Double check. Okay, cool. All righty. So, hello, everyone. Thank you for joining me to discuss Nashville's most recent urban tree canopy study. I'm Sarah Welz. I'm a certified arborist. As Kevin said, I sit on the board of the Tennessee Urban Forestry Council, and I work as the Urban Forestry Project Manager for Nashville. So my primary responsibility is to get trees planted around my city, but I also provide support with many of our department-wide projects, like the Urban Tree Canopy study we conducted last year. The study is on our webpage at trees.nashville.gov if anyone would like to look at it. and I'll have that web address at the end of the presentation as well. Okay, a little about geography and history to get us situated. Nashville and Davidson County form a metro government, which will be referred to as Metro Nashville for the purpose of this presentation. The metro area is approximately 336,000 acres with a population of almost 700,000 as of the 2020 census. In addition to Metro Nashville proper, there are 5 satellite cities in the county. These satellite cities use many of Metro's services and their canopies. I'm sorry, hang on. I just realized that there we go. Okay. These satellite cities use many of Metro's services and their canopies contribute benefits to the county, but they have their own governments and some degree of autonomy. And you can see those shaded on the upper picture. Metro Nashville has been a Tree City USA recipient for 28 years and has received the Growth Award from the Arbor Day Foundation for the last 12. The Urban Forestry Group wants to derive as much benefit as possible from our urban forest, and as part of Metro Water Services, we are the lead department for Root Nashville, which is a campaign to plant 500,000 trees in the metro area by 2050. One second. Okay. All right, now a crash course for my group and urban forestry efforts in Nashville. So it began as a series of mayor's initiatives, culminated into the previously mentioned Root Nashville campaign. This campaign was developed with the help of Bloomberg Associates, who identified the goal to plant 500,000 trees by 2050, both because it's realistic and it's easy to remember. It was launched in 2018 and just wrapped up its 6th planting season, and we've planted over 43,000 trees for the effort thus far. Where I work, the Urban Forestry Group, is in the Stormwater Division of Metro Water Services. Many people find this curious, as trees are more commonly associated with parks or public works, but it was and continues to be a good fit. Trees are defined by ordinance as a stormwater utility here because of their services in mitigating runoff and helping with stormwater infiltration. So trees save Metro Water Services money while also providing all the other stuff we love about them, improving water quality, stabilizing soil, and providing cleaner air, cooler temperatures, and habitat for wildlife. Besides conducting the UTC study, the Urban Forestry Group maintains an inventory of right-of-way trees, provides cyclical care for right-of-way trees, plans and funds planting and establishment care of trees on Metro-owned properties for the Root Nashville campaign, and heads up coordination between Metro departments on tree-related issues facing the city. So this UTC study is a massive topic with 11 years worth of data. So here's a general outline of what we're going to look at today. First, we'll go through the purpose of the study, the methods we used, and the geographic boundaries we chose to analyze. Then we're going to look at results for land cover, UTC for Metro Nashville and the county, and UTC changes from 2010 to 2021 for Metro Nashville. After that, I'll show you all UTC by geographic boundary, followed by the UTC trend analysis by boundary. During this section, we'll see a consistent pattern of canopy growth from 2010 to 2016, and then canopy loss from 2016 to 2021. And in the final section, we'll see some potential agents of UTC change, what the study concluded and recommends, and I'll talk about a few boundaries and stats in greater detail. Then we'll end with lessons learned and possible future directions from the data. Okay, so let's dive in. Section 1, study purpose, methods, and an intro to the geographic boundaries we looked at. The Urban Forestry Group in Metro Nashville is responsible for conducting an urban tree canopy assessment every 5 years. An urban tree canopy assessment quantifies current canopy, and it can also identify where canopy can be increased. If it includes a trend analysis, it can reveal changes in canopy over time. The data from the study can then inform the efforts of urban forestry groups, nonprofits, policymakers, and other stakeholders across the county when making decisions about it. So while a group is responsible for conducting the study, the information is for everyone to benefit from. With all that said, we had a lot we wanted to look at. The assessment mapped both urban tree canopy and possible planting area available in Metro Nashville. Then that information was analyzed across selected geographic boundaries to determine how it was distributed and processed to create trend analyses over an 11-year period. The results for current UTC and PPA were based on NAPE imagery from 2021 to provide the most current land cover data in Metro Nashville. NAPE stands for National Agriculture Imagery Program, and it's high-quality aerial imagery that's free to use. LiDAR data supplemented the analysis with a 10-foot height threshold placed to differentiate between canopy and non-canopy land cover. LiDAR stands for light detection and ranging, and it uses pulse lasers to measure distance, in this case, plant height. It was chosen for its effectiveness in identifying young trees, with anything below 10 feet in height classified as a shrub. Just to clarify now, water bodies were excluded from all percentages of tree canopy coverage versus overall land area. We utilized Planet Geo for this project, and they employed machine learning to create our land cover classes. NAPE and LiDAR were also used to assess canopy in 2010 and 2016, and all years were processed with the same technology for an accurate canopy trend analysis. The foundation for a UTC study is a good land cover data set, and creating this was the first step in the assessment. Planet Geo used land cover data from the Earth-defined US tree map based off 2021 NAPE imagery to create 6 classes of land cover for the study. LiDAR data then further aided the classification model to identify tree canopy and parse out shrubs and other vegetation. The 6 classes of land cover used in this assessment were urban tree canopy, shrub, other vegetation, aka areas of grass and open space, soil and dry vegetation, impervious surface, and water. We needed the study to quantify existing UTC, but another metric that we were interested in was area where tree canopy could be expanded, or potential planting area. To assess this, all land area in Davidson County that lacked existing tree canopy coverage was classified as either possible planting area, PPA, or unsuitable for planting. Possible planting areas were derived from the vegetation and shrubs layer. Unsuitable areas or area where it is not feasible to plant trees due to biophysical or land use restraints, like recreation fields, utility corridors, airports, etc., were manually delineated in the study, which you can see in the picture to the right. The unsuitable areas were then further broken down into unsuitable impervious, unsuitable vegetation, unsuitable soil, and water. So now that we've discussed land cover, UTC, and PPA, we come to the geographic boundaries which were assessed. We selected these 7 boundaries because of their common use by metro departments and for their ability to give us a comprehensive view of our canopy. They are as follows: Davidson County as a whole, Metro Nashville, our 2 service districts, transects, of which there are 7, land use, 11 of those, community planning areas, which total 14, and watersheds, of which there are 40. And that wraps up section 1. We touched on the study's purpose, the methods used, and the process to identify canopy and what boundaries we selected for analysis. Okay. I'm sorry, hang on. Okay, on to section 2. Where we're going to look at land cover statistics, UTC results for Metro Nashville and Davidson County, and the trend analysis for UTC in Metro Nashville from 2010 to 2021. Having percentages for each land cover class allows the identification of existing canopy and future targets for UTC. So here's what it looks like for us in Nashville. The study found that our tree canopy over pervious surfaces is 52%. Other vegetation covers 23%, impervious surface covers 17%, water covers 5%, and then tree canopy over impervious surfaces, soil and dry vegetation, and shrubs is all at 1%. Please bear in mind that water is included in this land cover data set, but this is a function of land cover classification, and water is not included in UTC data after this slide. Also, if tree canopy over impervious being 1% caught your eye, good. We'll talk more about it in section 4. Okay. Using the land cover data that was created with the 2021 NAPE imagery and LiDAR, the study analyzed the current canopy cover of Metro Nashville for UTC and PPA. We wanted numbers for this boundary to better understand urban forest metrics within the area of the county that is governed by Metro proper, and to set realistic expectations for how much we can expand the canopy. Of Metro Nashville's over 300,000 land acres, 56% was covered in tree canopy. Potential planting area totaled 72,400 acres, which equates to 24% of land area. So theoretically, we have a quarter of the county available to plant more trees. If all Davidson County stakeholders fully utilize this, the metro area could reach 80% canopy cover. 20% of land area was identified as unsuitable for tree planting. This includes the 17% of the metro boundary that is covered in roads and parking lots, 3% that is sports fields, and other unsuitable land areas and use types. The study also analyzed UTC and PPA throughout Davidson County, which includes our 5 self-governing satellite cities. I'm not going to spend a lot of time on this because the results were pretty much consistent with Metro Nashville. Davidson County had an equal tree canopy percent of 56, approximately 1% lower of available PPI, and approximately 1% more space unsuitable for trees. Davidson County also had 2% more impervious surface coverage compared to Metro Nashville. All right, that's UTC for Metro Nashville and the county done. Now, what did this assessment tell us about how our canopy has changed since 2010? Thanks to the trend analysis, I can tell you. We found that over the entire 11-year study period, Metro Nashville recorded a net gain of canopy of about 5,000 acres. Breaking that down, in the first half of the study from 2010 to 2016, there was a net increase of tree canopy of 5,770 acres. But then we see a downturn in the second half of the study from 2016 to 2021, which you can see on the picture. It's at loss of 670 acres. So we see a trend towards canopy growth in the first half, and then total cessation of growth, and actually a trend reversal towards loss in the second half. We'll talk more about possible causes of the downturn later. And that's it for section 2. We went over our land cover results, total UTC and PPA in Metro Nashville and Davidson County in 2021, and the trend analysis for Metro Nashville's canopy from 2010 to 2021. This showed that while we gained canopy overall, the gain trend from 2010 to 2016 reversed to canopy loss after 2016. Okay, on to section 3. This is where we're going to take a look at our geographic boundary data for service districts, transects, land uses, community planning areas, and watersheds. This is also going to be where we really see how a UTC study can flex its muscles to show canopy trends over time. Okay, first up, service districts. What are they and what does service district mean? When Nashville and Davidson County combined in the 60s to form what we now call Metro Nashville, the Metro government divided the land into the Urban Services District and the General Services District. The Urban Services District currently covers the former city of Nashville and the more developed areas of the county, and the General Services District covers the rest. As one may imagine, they are quite different from each other in character, but were they in canopy coverage? Overwhelmingly, yes. As could be expected, the more rural General Services District had significantly higher canopy coverage of 67%, while the Urban Services District had canopy coverage of just 39%. The potential for canopy growth is similar in either district, though, with 26% and 23% PPA for the Urban Services and General Service Districts, respectively. Overall, both districts experienced a net gain in canopy over the 11-year study period, amounting to a 72-acre gain in the Urban Services District and almost 5,200 acres gained in the General Services District. Looking closer at the Urban Services District, it experienced canopy loss between 2016 and 2021 of about 1,800 acres. The General Services District continued to gain canopy throughout the entire study period. But take a look at those highlighted numbers, though. Look at how drastically canopy gain decreased between the first half of the study and the second half of the study for the General Services District. And then, of course, after 2016, the Urban Services District basically lost all of the canopy that it had gained since 2010. All right, now let's talk transects. So transects are a system we use in Nashville that identifies county regions on a continuum of most rural to most urban, and they're useful for guiding planning, policy, and zoning. You can see how they divide the county on the left image. The green spaces are parks, the dark blue is rural, along the continuum to the bright pink downtown center. The two largest transects by acreage, rural and suburban, together make up 87% of all canopy. Although suburban contributed to over 30% of the UTC distribution based on the overall transect land area, it fell in the middle UTC percent range compared to the other transects, with 48% canopy coverage. The rural transect had the second highest canopy cover percent at 77. Unsurprisingly, the natural transect that encompasses most of the undeveloped spaces in Davidson County had the highest canopy percentage of 81. Only two transects, center and downtown, had 10% or less UTC cover. Because of their large land area compared to the other transects, rural and suburban together account for 80% of all PPA distribution. The suburban transect had the most PPA in terms of size. It's worth noting that despite having relatively low UTC cover and relatively high unsuitable areas for planting trees, the center and downtown transects each have potential to more than double their canopy cover. Looking at canopy changes over time, the urban transect experienced a 10% relative loss of canopy throughout the 11-year study period, equivalent to a net loss of 3.3%. The suburban transect is more than 4 times larger than the urban transect. However, an analysis of building permits from 2016 to 2021 showed that both transects experienced similar increases in new building square footage despite their difference in size. This concentration of development in the urban transect may be a large factor in its canopy loss. There was a net gain across all transects of about 5,200 acres of canopy over the entire study period, with suburban and urban contributing the most. But while the suburban transect initially gained over 3,000 acres of canopy in the first half of the study, it lost about 1,500 acres after 2016, which reduced the amount of canopy gained by nearly 50% overall. Okay. On to land use, which, as the name suggests, delineates property by its function. A couple name explanations for the table you're seeing. Residential 1 unit means single family residential. Residential 2+ unit is multifamily. Not assigned comes from GIS errors, because what's GIS without errors? But it's mostly open space. And vacant or farm is a category that farmland and undeveloped property are lumped together into. Overall, 4 out of 11 land use types had higher than the countywide canopy cover of 56%, while no land use types fell below 10% canopy cover. 2 land use types, vacant or farm and single family residential, contained a total of 83% of UTC distribution. 3 land use types fell below 25% canopy cover: industrial, commercial, and auto parking. But each of these land use types had significant PPA available at 17, 14, and 18% respectively. Looking at the UTC change from the first part of the study on the bottom left, every land use type experienced some degree of canopy cover increase, with the largest acreage gain of over 2,000 in single family residential, and the largest percent gain of 4.7% in industrial. It is interesting to note that while all land use types gained canopy in the first half of the study, 7 of the 11 reversed trend and lost canopy in the second half, which you can see on top. Single-family residential canopy change completely stagnated in the second half of the study after gaining canopy from 2010 to 2016. The largest loss in the second half of the study was of 381 acres of canopy in the multifamily residential type. Over the entire 11-year study period, on the bottom right, 2 land use types, multifamily residential and auto parking, experienced a net loss in canopy cover. Okay. Second to last geographic boundary, community planning areas, or CPAs, are delineations of neighborhoods by their character and composition. The table on this slide shows them in order from highest to lowest UTC cover as of 2021. The assessment found that 10 of the 14 community planning areas had below average UTC. The 4 areas that had higher than average canopy cover contributed to over 50% of all UTC across the county's land area. You'll see them highlighted on the table. These tend to be our more rural communities. The Jolton community planning area had the highest UTC of 75%. One community planning area downtown had less than 10% UTC. In terms of PPA, the Madison and Donaldson, Hermitage, Old Hickory community planning areas had the highest percent of PPA, with 30% and 29% PPA respectively. For the Donaldson, Hermitage, Old Hickory planning area, this equates to about 20,000 acres of PPA. If utilized, this planning area could theoretically raise its UTC coverage from 43% to 72%. It's worth noting that the downtown planning area offers 183 acres, which is 11% of possible planting space, which could more than double its canopy cover. Okay. Every CPA gained canopy in the first half of the study, with the largest percent gain in Madison, light green in the top right of the map. From 2016 on, though, half of the community planning areas experienced canopy loss, and there was a net loss of over 900 acres across all planning areas. From 2016 to 2021, Jolton, dark green, top left, experienced the largest increase in canopy cover of 2.5%, and Green Hills Midtown, red at the bottom, experienced the largest loss in canopy cover of negative 2.9%, or over 700 acres lost. Over the entire 11-year study period, 7 CPAs continued to gain canopy. 3 initially gained canopy in the first half, but had ultimately declined, and 4 community planning areas only lost canopy in the second half, but otherwise had a net gain. And we'll finish this section with watersheds. We wanted watershed UTC information because of what trees do for runoff, flooding, and their myriad other stormwater benefits. Our combined sewer sheds are included in this since trees help prevent combined sewer overflows. So we have a total of 40 distinct watersheds for this boundary. In general, our assessment found that watershed UTC was highest in watersheds on the edges of the county boundary as they got further away from the city center, which I roughly marked on the map with a star. 4 watersheds accounted for over 30% of the distribution of UTC, primarily those that are away from the city center. White's Creek watershed contributed the most canopy with over 23,000 acres of UTC. And that's that big one that I've highlighted. 3 watersheds had over 90% UTC. Those are on the west side at the very edge of the county. And 2 combined sewer systems fell under 20% canopy cover. And that's Kerrigan and Driftwood, also highlighted near the city center. They also had the highest amount of impervious surface coverage. Compared to the average PPA percent of the county, 15 watersheds had higher than average PPA. Most of the watersheds with higher than average PPA percentages are those that border the Cumberland River, which runs east-west and cuts through downtown. Okay. This graph is hard to read, but basically in the first assessment period from 2010 to 2016, all but 3 watersheds gained canopy, with the largest acreage gain of about 750 acres in the East Cumberland River watershed. Over the entire 11-year study period, total canopy gains offset the losses, with 29 watersheds gaining canopy. But once again, we see a trend reversal after 2016, with half of the watersheds losing canopy, which I've highlighted, and half of the watersheds gaining canopy, but many at a slower rate. Love's Branch, Cooper Creek, and Washington combined sewer shed saw slight decreases in canopy acres in the second half. Sycamore Creek had the largest gain in canopy of 432 acres, and Richland Creek experienced the largest loss in canopy of 431 acres. Overall, Sycamore Creek had the largest net gain in canopy, and Richland Creek had the largest net loss in canopy. And that concludes section 3. We looked at the 7 geographic boundaries we selected for analysis, which showed current UTC and PPA in each boundary. We also looked at the canopy trend for each boundary and saw a pattern of decline or deceleration after 2016. On to our last section, where we will describe what may be causing canopy changes, possible conclusions to draw from the data, and a deeper look at some particularly interesting stats from the study. We'll wrap up with some lessons we learned during the process of the study and future directions that data could point us in. In addition to the quantitative data, we also have some qualitative analysis from the study to help illustrate potential causes of canopy gain or canopy change in Davidson County. A survey was undertaken during the course of the study, and examples of some of the largest apparent causes of change were cataloged. Overall, the majority of canopy gains can be described by the following 3 categories: new tree plantings and associated growth, natural regeneration of areas previously classified as vegetation, and growth and expansion of canopy previously existing at the start of the study. Figures 19 and 20 show imagery of canopy growth in the second half of the study. Conversely, large losses of canopy can be attributed to clearing for residential and commercial development. Other potential agents of losses may be attributed to tree mortality due to extreme weather events. Examples include the derecho we suffered in 2020 and tornadoes in 2020 and 2023. Other agents include hydrological shifts or pressure from various pests and diseases, such as the ongoing impact from the emerald ash borer. It's estimated that 6% of our canopy will be lost to that alone. Imagery in figures 22 and 23 show losses of canopy in the second half of the study. The study makes recommendation for Nashville's canopy using the data gathered for each geographic boundary, which you can see listed on the right. The 7 bullet points that highlight some of the more interesting or useful data that was revealed by the assessment. Of obvious interest is the first fact, that our canopy has declined in the most recent study period, which may be indicative that despite the efforts of Root Nashville, more intense canopy management is appropriate. Bullet 2 does point out that there is an overall canopy growth trend over the past 11 years, but the loss after 2016 offsets the overall trend in this analysis. Continuing down the list, possible directions provided by this information include increased focus on planting in the urban service district, with particular attention paid to the urban transect. The vacant or farm and single-family residential land use types contain the majority of our UTC distribution. 2 of our combined sewer systems with the highest percentage of impervious surface would certainly benefit from greater canopy and have the PPA available to achieve this. And the last bullet is of particular significance. 9 out of 14 community planning areas aren't meeting their canopy goals. This warrants a closer look, as does our impervious surface percentage. So let's go over those in greater detail now. On this slide, you'll see 2 geographic boundaries we've touched on already: transects and community planning areas, CPAs. As a reminder, these boundaries define different things. Transects are a tool to systematize development intensity from most to least developed, and CPAs are a geographic delineation by neighborhood characteristics. It's important to note that each CPA contains multiple transect types, because transect types each have their own UTC goal based on a 2016 Metro Urban Forestry Master Plan. CPA goals come from the proportion of transect types they contain, which enables us to assign realistic UTC percentage goals for CPAs. Of the transects, which are on the top of the table, you'll see that the highlighted natural and rural are the only ones meeting their goals. Consequently, CPAs that contain a large proportion of natural or rural transect types are also meeting their goals. Areas like Jolton, Bellevue, and the Bordeaux, Whites Creek, Haines Trinity areas. Again, we can do this because transect percentages in CPAs directly influence that CPA's canopy goal. For the rest of the CPAs that contain less natural or rural transects, we can see that there's a correlation between communities with higher levels of development and lower UTC percentages. This suggests that the greatest benefits of our canopy are not being realized in areas that would impact the greatest number of residents in Metro Nashville, and serves as a bit of a reality check when looking at the overall Metro Nashville UTC data, especially with regards to citywide development pressure. Rural areas are carrying the team, while areas with high population and development densities are trailing behind. Ensuring that community planning areas are meeting their canopy goals would provide a more equitable benefit to the citizens that live, work, and play in each area. And then there's impervious surface coverage. Metro Nashville's almost 170,000 acres of UTC was divided into subcategories based on if it overhung pervious or impervious surfaces. There are a multitude of benefits associated with canopy coverage of impervious surfaces, such as localized cooling and reduced stormwater runoff. But the Canopy study showed that in 2021, only 1% of Metro Nashville's canopy overhung impervious surfaces. This highlights the need for greater focus on strategic planting near impervious surfaces to increase canopy coverage and provide greater stormwater and cooling benefits. Thank you all for sticking with me thus far. For those who may be interested in conducting their own UTC assessment or already in the process, some words of wisdom from Nashville. While this type of study provides a high-level view of the urban tree canopy, it can also be used to analyze change over time. And with adequate GIS data provided, it can scope in on particular areas of interest. Thanks to our inclusion of a trend analysis, we were able to determine that our canopy has decreased in recent years. However, it is important to remember that there are limitations to the accuracy of data. Constant improvement in resolution and technology can create difficulties in comparing imagery when studies are performed years apart. Additionally, the nature of canopy coverage imagery means that a UTC study can be at the mercy of a single snapshot in time. Say, for instance, that your imagery is from a drought that caused a temporarily reduced canopy. This can have some impact on your final results. As I'm sure you've all noticed, this information can be teased apart and interpreted in a million ways. Our department recognized this and wanted to provide this information to other stakeholders without any bias, just to let the facts speak for themselves. It may be worth coordinating with other governmental entities who could use the data to see what would most benefit the city as a whole. For instance, we coordinated with the planning department and watershed group and included several geographic boundaries at their behest to better inform their responsibilities to Metro Nashville. Some possible directions that I see coming from this study are comparing UTC and PPA with population density across different boundaries to determine where we could have the greatest positive impact for our constituents, as well as increasing focus on planting over impervious surface for maximum stormwater benefits. Finally, I'd say to put lots of eyes on the first draft of any study that comes back to you. My department found that the more people who looked at it, the more we improved the quality of the final draft. And that's it. On behalf of my department, thank you all for joining me on this webinar. If anyone wants to check out the study themselves, I've got the address for the website in the box to the right, and I can now take some questions.
Thanks so much, Sarah. That was super informative and very clear. Like, so many hands went into that study, and so to have to represent all those folks in a 45-minute period, I know it's a tough task. So thanks for pulling that all together. And I think particularly there at the end, the sort of, okay, what does this all mean and mean going forward? So I'm going to pass this over to Katie in a minute to share some questions received beforehand. But for those of you who are attending, feel free to put a question in the chat, and Katie will facilitate the Q&A with Sarah. So I'll pass it on to Katie.
All right, so Sarah, here's the first question we received before the webinar. It's kind of a long one, so bear with me. How does the assessment of the canopy account for most of Nashville being a distinctive barrens, mostly grasslands and open canopy woodland with scattered trees and patches of denser woods rather than a dense forest before development and conversion from agricultural to other uses? Weren't the denser forests concentrated on hills, the highland rim, outlier ridges intruding into the Nashville Basin, and along the waterways that had deeper soils due to annual flooding?
I was so impressed with this question. Whoever it is definitely has a better grasp of historical ecology than I do. But I think that the study is bound in its scope by its purpose. So because the study is only intended to look at the period between 2010 and 2021, we did not take into account the natural history of Nashville at all. But it is fascinating to think about, and I would love to be able to do like a comparative side by side of theoretically what the city looked like or what Davidson County looked like before even European settlement versus what it looks like now, and if UTC has gone up or down since then based on that question. So yeah, I guess my answer is we did not account for that, but it would be really cool to know.
Next question. The Kerrigan Basin is 17% tree canopy, one of the two lowest in Nashville. It is difficult to find qualified ROW planting locations. Can small ornamental trees be planted under electrical lines? What options are there for increasing canopy in the Kerrigan Basin? Yes, that's the question.
Gotcha.
Which,
Okay, so I'm going to assume that ROW means right of way for this question. And they're right. Kerrigan has one of the lowest canopy coverages, and it also has some of the most impervious surfaces. So it should be, it's good to be thinking about that space particularly. It also has a decent amount of PPA though. But as far as planting ornamental trees under power lines, NES does have a kind of like a guidance page on their website that people can refer to that helps explain what you can plant under power lines and like the distance to plant from. So I would definitely recommend going on that website. And also, if you're really interested in trying to get trees planted in that space, even if the right-of-way space is restricted, you can work with one of the nonprofits in the city who work with businesses or other private entities to plant trees on their property. I'm bound to only plant on Metro property, but the Cumberland River Compact, the Nashville Tree Foundation, and the Nashville Tree Conservation Corps, I would recommend touching base with any of those organizations to see what opportunities they could cook up together for planting in that space.
okay, next question. Please offer advice on countering those who are pro-development and have little or no regard for the importance and value of tree canopy.
Okay. Okay, so my recommendation, and I find that this works well for me professionally, is that I always try to engage in a way that tries to make other people feel heard and to listen to everyone's stake. It can definitely hurt my heart sometimes too when I see trees lost to development. But I tried to not let it make me feel adversarial because I find that usually shuts down a conversation before it could have been productive. But in many cases, trees are good for developers. They can make people linger longer in a shopping area or save costs on energy bills. So you can always try to win flies with honey instead of vinegar. And as always, you can advocate to your representatives. You can go to a council meeting or join one of Nashville's many activist groups that petition for change. And as always, vote for representatives that you feel represent your interests and your opinions about urban tree canopy preservation.
What is the percentage of canopy coverage in Nashville? How is this determined, and how might the city of Tullahoma acquire this software?
Yes. Okay. So I hope that some of that was conveyed throughout my presentation. UTC overall for the county is 56%. What was the second part of the question? Sorry.
Which you did touch on this in your presentation, but they also asked, how was this determined, and how might the city of Tullahoma acquire the software? Okay,
so it was determined using NAPE, which is the imagery that we got to get for free from the federal government. And then we also flew LiDAR over the city, and the pulse lasers measured the height of the trees. So our cutoff was at 10 feet. Anything below that was classified as a shrub. And then honestly, I don't exactly know how the sausage was made over at Planet Geo, but they are the folks who did it for us, and they used a lot of hardcore modern machine learning techniques, and they did all of the GIS work for that. So but that's who we worked for. That was, or worked with, that was our contractor. So if you're interested in doing your own UTC study, there are a number of vendors, I think, but that was who we went with. And, they did a great job. That's how we got our study. So, you can check out them. But you'll want to supply, the GIS information. So like your boundaries that you're looking at, we had to give all of that to Planet Geo because they obviously don't have all of our geographic boundaries. And then I think, I might be wrong about this, but I think we had to pay for our own LiDAR to be flown for this study. If my supervisor is on here and I am wrong about that, please forgive me. But that is what I suspect or remember from the planning process for this.
How do we focus our Root Nashville tree bank and other tree investments in the areas where it is most needed? What impervious surface changes would you like to see happen to improve tree canopy?
Yes. Okay. So I would really like to see more right-of-way plantings in Nashville generally. I think that the benefits that right of trees offer are really, really, really myriad and really important. They definitely help clean our air. They help mitigate a ton of pollution. They also have the hardest lives. So that's something to keep in mind, is that it can be difficult with right-of-way trees because they just have a lot stacked against them. But by planting tough species in right-of-way spaces, I think that would be a good way to go with that. And as far as tree bank goes, I'm not sure if everybody on here is familiar, but I can tell that this question was asked by somebody in Nashville, because we have something in the city that we leverage. It's a funding source called the tree bank. Basically, money goes in when developers can't replant enough trees to meet code after they've developed a property. So in lieu of planting trees, they can put money into this fund. And then my department manages the tree bank. Other departments can use it too, but we are kind of the ones who use it most often. And we share it with nonprofits most often. So as far as using the tree bank, that would only be applicable for metro property. But I always like to look at planting on parking lots because that's something that every property has in Nashville, is everybody's got a parking lot. So that's another thing that you could focus on, is trying to plant around those spaces and just really concentrating on areas of impermeable surface. And then also I would love if there would be more efforts to depave, and that's something that one of our nonprofits, the Cumberland River Compact, has done before in some of our parks. So we have done some depaving and then planting work. And I think wherever that opportunity is available is a great option for improving the impervious surface percentage that we have currently.
Is there any plan to overlay the UTC assessment data over surface heat maps or socioeconomic data to identify most vulnerable communities?
Yes. Okay. Well, okay. So there isn't a plan for that right now, but what I can say is that I have looked at the climate justice tool. Kevin, can you remind me of the full name of that? We used it for our grants.
Yeah, the Climate and Economic Justice Screening Tool, CEJST. I'll put a link in the chat.
Yes. Okay. Thank you. So I have looked at that tool and compared it to our UTC data. And I'm sure it doesn't come as any surprise that there is reduced UTC in all of the census tracts, or UTC is less than average or declining in spaces, in census spaces that are environmentally or economically disadvantaged. And those align really well with our community planning areas. So if you look at like Madison, that's on the mayor's heat map for one of the hottest spots. And if you look down in South Nashville in the Antioch area, that aligns with area where Canopy, where the community planning area isn't meeting its goal for UTC. So we plant trees everywhere that we can, but this data can be useful for the nonprofits or for other activist groups if they want something to look at and say, hey, this area isn't meeting its CPA, this area isn't meeting its UTC goals. Let's do something and get trees planted there. Because I really love planting at schools that are in areas that are like typically considered disadvantaged, or in those census tract areas that are on the climate justice tool. But I can't do it by myself. So I think it would be a good thing to focus on, and we have the data now from the study to show that these areas need more help.
Canopy overhang on impervious surfaces makes sense for lowering heat island temperatures, but can you speak more specifically to how absorption of stormwater runoff works in impervious areas?
Yes. Okay. So it's kind of, the problem is kind of that absorption isn't allowed to happen, because if you take a tree that's in a field and it gets rained on, the water infiltrates the soil, and then the roots are able to pick it up and evapotranspirate it out of the soil. In an area that's heavily paved, or in for a tree that is in a space surrounded by impervious surfaces, what's going to happen is you get runoff in those impervious spaces, and the roots aren't able to conduct water out of the soil because everything's paved over. But the other things that trees are great for, as far as like stormwater mitigation goes, and that's helpful when it overhangs when it overhangs the impervious surface, is that the leaves literally capture rainwater before the rain droplets can even hit the ground. So you're reducing stormwater that way. And we also love them because they reduce runoff, and where roots are able to evapotranspirate water out of the soil, we get reduced flooding, and we also get reduced erosion from the roots, like holding everything together. So we do want it to overhang because it captures rainwater. But I guess I'm thinking about it, and it's like there is an amount of limitation to how much evapotranspiration can happen, because the roots aren't able to access water that is above an impervious surface.
Can you give us a rough idea of the initial and ongoing cost of this UTC?
Oh, that is such a good question. I should have looked at that before this. I am not the person who handles all of the finances for my department. That is my supervisor, and bless her. But that's something I could get back to about. So I kind of stopped sharing my screen a little bit early, but I can share it again if that's okay, so that people can send me emails. Here, let me share that. Okay. So yeah, this is one of those cases where I just have to be like, I do not know the answer to that one, but please email me and I can get back to you.
Okay. And I know we're getting close to time. If it's okay with you, I'm going to keep asking you questions that we've received, but if anyone needs to hop off at 1, go ahead and hop off. But Sarah, are you good to continue answering other questions?
Yeah.
Okay, great. Are the results surprising given the significant increase in population and development over the last couple decades?
I wasn't sure what to expect. I don't think that anybody was really sure what to expect. Everybody can see how much Nashville is developing, but we weren't sure how much of an impact it was going to have. There had been previous studies done, but this was the first one since 2016. So the first one since the pandemic, since kind of the change economically and people leaving larger cities and moving to mid-sized cities. So I guess I would say I'm not surprised because I didn't know what to expect at all from it. But since I've looked at the data, I don't find it shocking. It makes sense to me. And I think that the decline from 2016, I moved to Nashville in I think 2021. And I'll say that in the 3 years that I've been here, there's always development. And I see new buildings going up constantly. But I also keep in mind that tree growth is really slow, and it's not something that you notice all at once like you do when you see a bunch of trees get cut down. So there was an expectation that there'd be some canopy growth and expansion, but I didn't know how much it was gonna be offset by development. And as we see from the qualitative study that was undertaken throughout the UTC assessment, it looks like there's a few factors that are going on that are reducing our canopy and definitely reducing expansion of our canopy. How much of it is development, I'm not sure, but I think it's definitely a factor. But yeah, I just didn't know, so I'm not surprised.
What was the imagery resolution, and what would you suggest is the optimal resolution for UTC analysis?
Okay, that's another email me question, and I'll get back to you with an answer. Good question though. And I'm curious about that too. I don't know what the resolution was. I think it was pretty good though, because NAEP is a federal program and a lot of people use it for UTC projects like this. So yeah, I'll get back to you. Email me.
What is the coordination of the UTC study with single tree census data? For example, Neil Letson's Heat Island study and census of trees that are still surviving downtown. Sorry, this question was a little jumbled whenever I copied it over. I think this says, let's de-pave Broadway. Let's make a prize for places that do well on planting, such as the new courthouse, some Dollar General stores.
Okay. I'm all for de-paving where appropriate. I'm not sure if anybody would like for Broadway to be de-paved. I think that what this person is trying to communicate is that they're seeing a lot of excessive pavement in the city. And I know that there are some Dollar Generals or Kroger's where they just have these massive parking lots that aren't fully utilized. And so, while I think that is a wonderful thought, I also think that we need to work on our transit system and make sure that people are able to get around without cars. And also that trying to get a private business to depave their parking lot is that would be a large effort. And it's definitely outside of my wheelhouse.
And one person asked if you could talk about street trees' impact on canopy.
Yeah, so I think I think that street trees, so we have planted a ton. We have planted a ton. My group, the Urban Forestry Group, is very young. I think we were formed in like 2018. But since our inception, we plant hundreds and hundreds of right-of-way trees each year. And then our nonprofits also plant tons of right-of-way trees each year. So right now it is a big focus. And we do actively maintain the ones that we have. But it won't be until years from now when these trees have reached maturity that we're really seeing a difference in like the value and their contribution to UTC overall. But they are really vital. And right-of-way trees, planting right-of-way trees has a ton of benefit. And they clean the air, they cool things down, they help with erosion and stormwater capture. And they're also traffic calming. So a really cool thing about right-of-way trees is they make people drive slower and more safely. So we feel very positive about right-of-way trees in Metro, and we're trying to plant as many as we can, but we didn't like parse them out in the data at all throughout the study. I think it was something that we looked at trying to do, but an interesting thing about Nashville in particular is that our right-of-ways are a little scattershot, and our GIS data isn't always perfect for it either. So I think it was just something that was not measurable. I think it was a thought to try to get the right-of-way trees kind of separated in the study, but we couldn't do it. But we have done iTree Eco modeling of our right-of-way trees. So I do have some numbers for that. I think it's like a lot of, I can try to pull it up. One sec. I have it somewhere in here. Okay. You guys can ask me another question while I look for this if you want to.
Those are all the questions I have. If I missed anyone, please feel free to put your question in the chat now. But those are all the questions I have at the moment.
Okay. Let me provide an answer to this really quick, and then I guess we'll be ready to wrap up. Thank you guys for having me, and thank you to everyone who's stuck around for this long. I know it was a really dense subject, because there's, the science of all of it. There's the technology aspect. There's all of the GIS stuff, and then there's all of the kind of how to interpret the data aspect. So it was a lot. So thank you guys. Okay, so our right-of-way trees provide $9.85 million in total benefits annually. And we have for every dollar that we invest, we get back $3.18 worth of values.
And while you were searching for those, we did get 2 more questions, and one of them is about right-of-way planting. She said she's still fuzzy on what right-of-way planting is.
Okay, so the right-of-way is the space that adjoins somebody's private property, and oftentimes it's like a planting strip, or it's the back of a sidewalk up to a person's water meter, and it has a lot of utilities. Typically it's kind of space where Metro just puts a ton of stuff, so you can have gas lines, water lines, and then all of that stuff goes up to your house, but those are private utilities. The public stuff is in the right of way. And so in Nashville, it does differ depending on where you are and what you're looking at. But if you want an easy rule of thumb, right of way oftentimes can be measured by the end of a road to your water meter. And whether that's grass or a sidewalk or a bike lane or something else, that is considered the right of way.
Okay. And I'm going to make this the last question because I don't want to go too far over time, but are we measuring attrition of planted trees?
So like, are we measuring survivability? I'm gonna guess that means survivability. So yes, a little. My department gets survivability numbers back at the end of each season. It is not by species. It isn't by planting location. It's nothing fancy. It's just how many trees survived from each project. And while I think it would be really interesting to look at tree survivability by species throughout, our projects. It's not something that we currently have the capacity or personnel to do right now, which I find is a problem often with conducting survivability studies. But maybe one day, if I ever have an intern, that's something that I will look into doing.
All right. Well, it's almost 10 after. Sarah, thank you so much for the presentation and sticking around and answering so many questions. Katie, thank you for running through all those. And to everyone who joined, thank you for joining, and for, there's over 40 of you who stuck around. And so I think we could probably hang out all afternoon. But Sarah, I know you got other work to do. So thank you again, everyone. We do these webinars every month. Next month, we're going to have Jack Payne from the National Champion Tree Program. We're still looking for topics for a few other months later this year. So please, if you have anything that you're really curious about, send it our way. And then also, if you really enjoy meeting virtually, we have confirmed our in-person conference. It's going to be November 14th and 15th in Nashville at the Garrett Bennett Center. This is open to anyone statewide, or even if you live regionally and want to come join us. It's a really great event. We'll be sending out more information on lodging and registration details very soon. But we welcome you to continue joining our virtual webinars each month, and then hopefully in November for our conference. Thank you again. Thank you, Sarah, Katie, and everyone, and have a good afternoon.
Thank you.